Hello, ladies and gentlemen. Welcome back to Physics 30, Chapter 1, Momentum, Lesson 3, Momentum in One Dimension, Part, God help me, 3? So here, the third type of collisions are actually explosions. Usually the object is at rest, and I want to stress usually, was at rest initially and then breaks into two separate pieces traveling in opposite directions. Example 5. Mr. S is heating a 250-gram pizza pop in a microwave when it explodes. 100-gram piece moves left at 3 meters a second. What's the velocity of the second piece? Well, here we go. The before. We have the pizza pop. It's sitting there. The initial is 0. And if the initial velocity is 0, then the initial momentum will be 0. Right? After, splop, we get a chunky bit going this way, and a chunky bit going that way. So, let me see, how does this go? So, a 100-gram piece moves left at 3 meters a second, so momentum final. M left, velocity left. Now this is 100 grams, 0.100 kilograms. And the velocity going left is 3.0 meters a second, but it's going left, so that's minus 3. So this is minus 0.30 kilogram meters per second. Now, notice I forgot the momentum of the piece going right. Momentum of the piece going right, velocity of the piece going right. That could be V final or V right, whatever. So how much is that? How much does it weigh? Well, it's 250 grams in total, and a 150-gram piece moves left. So this is 150 grams, or 0.150 kilograms, moving at a velocity V. So 0. Plus 1.50 kilograms times V. Now note, the final momentum will equal the initial momentum, which is 0. We start with nothing, we end with nothing. So I would add 0.3 kilogram meters a second to both sides. So this works out to be, what is it? 0.300 kilogram meters per second equals 0.150 kilograms times V. So velocity 0.3 divided by 0.15, which is plus 2 meters a second, or 2.0 meters a second right. Okay, so far so good? Well, I hope so. Now, another example of an explosion. Target practice. Recoil. Bailey is target shooting with a revolver. If she shoots a 9.5-gram bullet at 270 meters a second, what's the recoil velocity of the 1.6 kilogram revolver? All right. So before, velocity of everything is 0. So the momentum initial is 0. After, what do we got? We've got the bullet, and we got the gun. So momentum of the bullet, momentum of the gun. So momentum final is momentum of the bullet plus the momentum of the gun. Now, depending on my mood, I might say momentum. I'll probably just go mass, bullet, velocity, bullet, plus mass, gun, velocity, gun. And I might go capital B, small b, because, whatever. So, the final velocity will be 0, just like the initial velocity. Now, the mass of the bullet, velocity of the bullet. So, for the bullet, mass of the bullet is 9.5 grams, 0.0095 kilograms. Velocity is 270 meters a second. Now it's to the right, so that's plus 270. Now the mass of the gun is 1.6 kilograms, and the velocity of the gun I don't know. That's what we're asked to find. Times velocity of gun. Right? Now, I'm looking at this and I'm going, I cannot do this in my head. So I got to grab Mr. Calculator. 0.0095 times 270. 2.565 kilogram meters per second. So that equals 0 plus 1.6 kilograms times velocity of gun. So what do I do next? I think it's fairly obvious. Subtract 2.565 kilogram meters per second from both sides. And then divide both sides by 1.6 kilograms. So divide by 1.6. And I've got I got 1.60 meters a second. Now that should be negative. I forgot to put my negative sign in there. Or 1.60 meters per second left. Actually, I don't think I have to put the square brackets on there. Just call it left. Okay? That's what I need to be able to do. So that's explosions and recoil. Now you may vaguely remember recoil questions from Physics 20 where we talked about the acceleration. Newton's third law: for every action there's an equal and opposite reaction. There we were talking about acceleration. Now we're talking about velocity. So this last example is a particularly important concept. The impulse, a change in momentum of two objects, excuse me, that start together at rest must be equal in magnitude, direction, must be equal in magnitude and opposite in direction after breaking apart. And missing words, change in momentum after breaking apart. The bullet and the gun have very different final velocity. I'm not going to speak English. The bullet and the gun have very different final velocities, but they have equal magnitudes of impulse and force. All right? Anyway, that's what I need to be able to see. So, I'm going to stop here. There's two more example questions I want to do, but this video is getting kind of long, and there's one more thing I want to stress there. If you have any questions, shoot me an email. Otherwise, good luck.